Hello everyone. Today we are discuss here from the unit solubility of drug. What do you mean solvent solute interaction? Exactly how solvent solute interaction takes place? What is the mechanism which is involved into the solvent solute interaction and different types of solvent, that is polar solvents, non-polar solvents and semipolar solvents. So we will discuss about this point today in this video. From the bit solvent solute interaction or solute solvent interaction. Whenever any solution it will form, or whenever we are going to add the solute into the solvent, and it will get form a homogeneous mixture, there must be the interaction between two components. And these two components are nothing but one is solute, another is solvent. Solute is component which is present in less quantity. Solvent is component which is present in more quantity. But question will be in your mind, exactly on what basis we are going to select the specific solvent to solubilize or to dissolve a specific solute. The one important theory and an important concept behind the selection of solute and solvent. And this theory, this principle is none other, it's the like dissolves like. So for preparation of the homogeneous mixture or the clear solution by dissolving solute into the solvent, that is to dissolve the solute, we have to choose, we have to select a suitable solvent in which it will be completely soluble. And this solvent which are selected on the basis of principle like dissolves like. What do you mean like dissolves like? It is simple. A solute dissolves best in solvent with similar chemical properties. Means what? If the chemical properties of solute and solvent are same, then that solute, it will be easily dissolved into the solvent. That is like dissolves like. This is in case of chemical properties. Another way, if the two substances, they are having the similar intermolecular force of attraction, they are having the similar intermolecular forces, These are likely to be soluble in each other because everything is similar. Whatever the chemical properties are present or shown by this substance, these are similar. Intermolecular forces present into the two substances, that is nothing but the solute and solvent, these are similar, and on that basis the similar properties, similar characteristic substance, they will solubilize easily. And this principle which is used, this principle which is applied while selecting the solvent to dissolve the specific solute. Moreover to this here, drug. And that's why it is called as like dissolves like. Then which properties? For example, polar solute dissolve in polar solvent. You are aware that the solvents which are maybe polar, which are maybe non-polar, which are maybe semipolar. So in this what happen? What are the solute molecules which are polar in nature? They will dissolve in polar solvents. Example is salt and sugar dissolve in water. So what do you mean polar solute? What do you mean polar solvent? Second is non-polar solute which are dissolved in non-polar solvent. Example is naphthalene dissolved in benzene. Both benzene and naphthalene which are in non-polar form. In first case, polar solute and polar solvent, both the solute and solvent which is in polar nature. So what do you mean polar, and how these polar solvents they are showing the solubility phenomenon? The mechanism of polar solvent, it is mainly depends upon the dielectric constant. These polar solvents, they are showing the higher dielectric constant. The value of dielectric constant is high, and they form the hydrogen bonds. And that's why polar solvents, they are showing the more solubility. And if the properties of solute and solvent which are same, if both are polar, that is on the basis of like dissolves like, they will get easily dissolved. That is polar solute and non-polar solute, how these are respectively dissolved into the polar and non-polar solvents. Switch mechanism which are involved into the solubility. If it looks towards the first type, first nature of solvent, it is polar. When solute solvent interaction is takes place, in this case, how polar solvents, by which mechanism polar solvents, they will make solubilize the solute into the solvent. The mechanism involved in polar solvent is dielectric constant and hydrogen bond formation. So what do you mean dielectric constant? What is it exactly? You know that dielectric constant, it is a physical property. It is a just simple ratio between the permittivity of the medium to the permittivity of the free space. The dielectric constant, which is affected by the attractive forces which are exist in between the atoms and molecules. Second is hydrogen bond formation. The polar solvent, they have the tendency, they have the capacity to form the hydrogen bridges or the hydrogen bonds with the solute which is present into that solvent. And third mechanism, it is dipole interactions. What do you mean dipole interaction? Before this, what do you mean dipole? Dipole is just simply, let us see, this is the one molecule, and in this one molecules we have the two different ends for this molecule, and within this same molecule, if you get the positive and negative poles within itself at two different ends, these two different positive and negative poles, the magnitude of the at one end of the molecule is positive, the magnitude at one end of the molecule is negative, that is on the basis of electronegativity. And the attraction between such types of the dipole, which is involved in the mechanism how the polar solvents, they will make solubilize the solute. And the example is water and ethanol. If we mix the water and ethanol, they will get solubilized. They will get dissolved. They will form the homogeneous, a single phase system. Single phase system means, let us see, in this beaker, we have taken the solvent, and in this solute we are going to add the solute. So after addition of this solute into the solvent, when you mix these components, whatever the systems we are getting, whatever the mixture you are getting, it must be clear. In simple language, we can't separate solute and solvent from this mixture at that condition, at that situation. We can say these are completely dissolved. We can say these are in single phase. We can say the mixture is in homogeneous form. And in this case, we can't able to separate solute. We can't distinguish the solute and solvent separately because they are looking in the single phase. They are not separately. They are in mixture form. Second type of solvent is nonpolar solvent. In this nonpolar solvents, the mechanism in the solubility which is involved, These weak van der Waals forces. An example of the non-polar solute and solvent is what are the fats, what are the oils, alkaloids, bases which are dissolved into the solvents like carbon tetrachloride and benzene. So such types of non-polar solute which are dissolved into the non-polar solvent. Third nature of solvent is semipolar solvent. The semipolar solvents, they will make solubilize the solute into this by the mechanism of inducing a certain degree of polarity. That is, you can say that induced polarity. This means this substance, they are just inducing the polarity of the other solvent. If you see in this example, acetone increases solubility of ether in water. What you are going to do here? We are going to dissolve ether in water. Acetone is the third agent. So what is the role of acetone here? This acetone is just increasing the polarity of ether and water. And by inducing the certain degree of polarity in the mixture of ether and water, this acetone is playing the role of polarity inducer. And acetone is enhancing the solubility of ether and water as a semipolar solvent. So this is happen, and these are the different types of the different natures of the solutes and how, by which mechanism they are making homogeneous mixture. Let us see when the polar solute and polar solvent is present into the system. Example is ammonia dissolved in water. A polar ammonia molecule dissolved in a polar water molecule. And these molecules will mix readily just because of both the types of molecules which are involved, which are engaged. They have the ability to form the hydrogen bonds. Means what? The ammonia molecule itself have the hydrogen bonding capacity. Water molecule itself have the hydrogen bonding capacity. And when this ammonia and water, they come together, they will start to form the linkage, from the hydrogen bridges. That is, you can say the hydrogen bonds between the ammonia molecule and water molecule. So here, the intermolecular attractions are roughly equal. The molecules can break away from each other and form a new solute. That is, solute is ammonia. Solvent is water, hydrogen bonds. In earlier lecture, we have discussed regarding the attraction forces between the solute-solute molecule, attraction forces between the solvent-solvent molecules, attraction forces between the solute and solvent molecules. And what happen if the forces, if the solute which are greater, solvent which are greater, what happen in between the forces of attraction between the solute and solvents which are greater than solute and solvent, or what will happen the forces of attraction between the solute and solvent molecule, it is equal. And exactly, the forces of attraction between the solute and solvent molecule If it is equal by the definition of like dissolve like, by the principle of like dissolves like, these are capable to solubilize in homogeneous form. And the forces involved in the intermolecular attraction between the solute-solute and solvent-solvent molecule, if it is same, so they can easily break each other's. To break the solute-solute bonds, to break the solvent-solvent bonds, it will not be difficult because they have the same forces of attraction. And once they break the bonds between the solute-solute and solvent-solvent molecules, these solute molecules, they will be spread throughout the solvent, that is water. And the next step which will initiate, that is formation of bond between solute molecule and solvent molecule. That is here the hydrogen bond formation process, it will start between the ammonia molecule and water molecule. That means what happened? The forces of attraction, the intermolecular attraction between the ammonia molecule and water molecule, it will start. And once this process will start, and when this forces of attraction, when this intermolecular attraction is greater as compared to the solute individually and solvent individually, that system it will move, that system it will start to form the homogeneous mixture by formation of the hydrogen linkage, hydrogen bond between the solute and solvent. And in this case, ammonia dissolved in water, ammonia and water, they will form the hydrogen bonds and they will form the homogeneous clear mixture, that is single phase solution. That is how both the polar solute and polar solvent, how they form the homogeneous mixture. Okay, understood how ammonia dissolves in water and how like dissolves like in case of polar solute and polar solvent. Compound in water decreases. That means what happened? The non-polar groups which are more in comparison to the polar groups. So what will happen? Net polarity of that substance, net polarity of that molecule, it will be less, of course. And if the number of polar groups which are more in that substance and in that molecule, definitely its net polarity it will be more. That totally it depends upon the structural features. Let us see the straight chain monohydroxy alcohols, aldehydes, ketones, and acid with more than 4 or 5 carbon atoms cannot enter into the hydrogen bonded structure of water and hence are only slightly soluble. If the number of carbon atoms which are present into that substance are more, that means what happened? Non-polar groups which are present in the large amount and hydroxy group is only one, that is methanol, ethanol. In this number of carbon present which are just 1 or 2. As we are moving, as we are leading towards the propanol, butanol, hexanol, octanol, what will happen? Hydroxy group presents, it will be remain same, it will be remains monohydroxy, but number of carbon atoms presents, the length of carbon chain, it is more. So that's why the number of carbon atoms which are more than 4 to 5 carbon atoms, they will show the slightly solubility, because only one hydroxy group is present. The quantity of the non-polar substance, it will be increase. So this is again reason in the solubility. If you look towards this slide, here the additional polar groups are present in the molecules as found in the propylene glycol. Now we see in earlier sentence, in earlier slide, what I told you, the monohydroxy alcohol, if they are having the carbon atom more than 4 to 5, they are showing the slightly solubility because of the less polarity. Here, it is exactly opposite to this. What this sentence, what this point is telling here, if the number of polar groups, polar group in the sense here, hydroxy groups, which are found in the substance in the more amount, that is, let us see here, ethanol, diethanol, two hydroxy groups are present. That means one excess polar group is here as compared to the ethanol. So definitely diethanol, it will show the more solubility, of course, because more polar nature. Let us see here, propanol, one additional hydroxy group is present, it will becomes propanediol, that is propylene glycol. It is also showing the more water solubility. Glycerin, glycerol, that is propanediol, again it is showing the more solubility. So here, what is the conclusion? The number of hydroxy groups, if increased, number of hydroxy groups, that is the polar groups which are present into the substance, if these are more as compared to the non-polar groups which are present into the substance, the solubility of the substance, solubility of that molecule, it will be increased, and these ethylene glycol, propylene glycol, glycerin, glycerol, these are used as a solvents for the solubility enhancement. So one more structural point which is important, the branching of the carbon chain reduces the non-polar effect and leads to the increased water solubility. You can take the same example. If you take the same example in this butanol, the only one hydroxy group is present in tertiary butanol alcohol and N-butanol. Let us see tertiary butanol alcohol. It is look like this. The structure of tertiary butanol alcohol. N-butanol structure is like this, or it may be like this. These both are same. Just what happened in tertiary butyl alcohol? The carbon chains which are present in the form of branching. So due to this, what will happen? The polarity of the butanol, it is increased. Means what happened? Non-polar effect of this butanol is decreased. And due to the increase in polarity, this tertiary butanol or tertiary butyl alcohol, it is showing the more solubility, it is showing the more miscibility in all proportion with water. So we can mix this tertiary butyl alcohol in water at any proportion. In every proportion, that tertiary butanol is ready to show the solubility in water. But in case of N-butyl alcohol, it will dissolve to the extent of about only 8 gram in 100 ml of water at 20 degrees Celsius. So what it indicates? The N-butanol alcohol, it will be dissolved into the water. In what proportion? 8 gram in 100 ml. At what condition? 20 degrees Celsius temperature. In case of tertiary butyl alcohol, is this applicable? No. Because tertiary butyl alcohol, it is soluble in all proportion because the greater polarity which is present into the tertiary butyl alcohol because of reduction into the long chain of carbon and just branching of the carbon, that is branching of the carbon, it will increase the polarity and it will reduce the non-polarity of the substance. Next is repeatedly I explain the hydrogen bond and dipole forces. So in hydrogen bond, let us see here. This yellow color, it is an hydrogen atom, and this red color, it is any atom which is present into the solute. This hydrogen, as usual, it is having the positive charge. The atom which is present into the solute molecule, it is having the negative charge. And due to the attraction between this negative charge and this positive charge, this linkage, it will be formed here or here, this linkage between the positive hydrogen and negative atom which is present into the solute molecules. And the such types of the linkage, such types of the bridges, they will be more in between the solute and solvent, and at the end we will get the homogeneous mixture, homogeneous solution. That is, hydrogen bonding is the attractive interaction of the hydrogen atom with an electronegative atom. It may be nitrogen, oxygen, or any other atom which have the electronegativity and which is present into the mixture. Second is the dipole-dipole forces. This is due to the electrostatic interactions of permanent dipole into the molecule. So dipole, as earlier slide I have explained, dipole is just two poles, they will get formed into the single molecules. That is, the one is the positive charge and one is the negative charge. So like this, due to the dipole formation, due to the different charges which are present at both the ends, they will start to attract with the another molecules, and again due to the dipole-dipole interactions, let us see, this is positive, this is negative, this is positive, this is negative, this is negative, this is positive, this is positive, this is negative, this is negative, this is positive. So such types of the interaction, it will get start here also, it may be negative and it will be positive, there will be the interaction, again here one dipole, it will come negative, positive. So this interaction branching across the solution, it will form, and this dipole-dipole forces of attractions, they will increase the solubility of the solute into the solvent. So in case of non-polar solvent, what happened in case of non-polar solvent? As we have differentiate between the polar and non-polar solvent. In non-polar solvents, they are unable to reduce the attraction between the ions of strong and weak electrolytes. Why these are unable to reduce? Because in strong electrolytes, there is a greater attraction, greater force of attraction between the molecules. And unfortunately, the non-polar solvents, due to their less dielectric constants, less dielectric constant value, these are unable to break the attraction between the solute-solute molecules. Here, solute-solute attraction present between the electrolytes, it is more. They are unable to form the hydrogen bonds also in case of non-polar solvents. Again, non-polar solvents cannot break covalent bonds and ionize weak electrolytes because they are atropic. Atropic means there is a no hydrogen atoms. And as there is the no hydrogen atom, there will not be the chance of the formation of the hydrogen bonds. There will not be the chance the formation of the hydrogen bond bridges, and they will not break whatever the covalent bonds which are already exist into the solute-solute molecules, and they will unable to form the covalent bond and hydrogen bond between the solute and solvent molecules because these are in atropic nature. Non-polar solvents can dissolve non-polar solute through the weak van der Waals force of attractions. That is, like dissolves like. These non-polar solvents only dissolve the non-polar solute. Non-polar solvents dissolves non-polar solvents. How? By weak van der Waals forces of attractions. That is, like dissolves like. The force involved is van der Waals force of attractions. The example is solution of oil and fats in carbon tetrachloride or benzene. This carbon tetrachloride and benzene, these are non-polar. Oil and fats, these are again non-polar. And these may be, and these are soluble into the this non-polar solvent, that is carbon tetrachloride and benzene. This is the example of the non-polar solvent. Next is the semipolar solvents. The semipolar solvents such as ketone can induce a certain degree of polarity in non-polar solvent. For example, benzene, which is readily polarized and becomes soluble in alcohol. In initial slide, we have explained in that chart how these semipolar solvents, they will show, or how they will increase the polarity of the other solvents, and how these are helpful to solubilize the one solute into the another solvent. That means the semipolar solvents, these are just act as an polarity inducers. Example is benzene is solubilized into the water due to the addition of ketone. That is, example is acetone. They can't act, sorry, they can act as intermediate solvent. Means what? These are not directly act as a solvent. These are just act as an intermediator between the solute and solvent by inducing the polarity into the solvent to bring about miscibility of polar and non-polar liquid. Also, these ketone or the semipolar solvents, as they are acting as an intermediate, they will just increase the miscibility between the polar and non-polar solvents. By this way, these are act as an intermediate solvent. Example, we have already discussed acetone increase the solubility of ether in water, or acetone increase the solubility of benzene in alcohol. The propylene glycol has been shown to increase the mutual solubility of water and peppermint oil and of water and benzyl benzoate. This is the activity of the propylene glycol. Look towards this slide. This slide is indicating that as here the dielectric constant of the solvent which is mentioned, the dielectric constant of water is 80, glycols 50, methyl and ethyl alcohol it is 30. These are mentioned approximately, and here the solute, okay, different types of the solute these are mentioned. So this chart is just for understanding what will the effect of the change in polarity, that is what is the effect of the change in dielectric constant on the solubility. As the dielectric constant it is decreased, the solubility of that substance into the water it is decreased. That means if the solute it is, if it is more polar, then only it will be easily solubilized or completely solubilized into the water, or its water solubility it will be more. Okay, water in water it will be of course more soluble. Glycol again it will be soluble, but when you leads to the hexane, benzene, tetrachlorides, mineral oils, fixed vegetable oils, fatty acids, the fats, its water solubility it will be decreased. This is due to decrease in the polarity, and polarity is decreased due to the low or less dielectric constant value. If we look toward this graph it will indicate, if you plot the solubility on the y-axis and the solvent polarity on the x-axis, as the polarity it will get increase, solubility it will get increase, and this is observed in case of the polar drug. If the drug which we are going to use, if it is more polar, of course it will show the its a solubility proportion to the polarity, and if the solvent polarity is more, it will show the more solubility. If in case of semipolar drug, it will just show the intermediate solubility as compared to the polar and non-polar. If you have the non-polar drug, its solubility again it will get increase or decrease. The solubility it will get decrease as the polarity of solvent it is more, because polarity of solvent is increasing, polarity of the solvent is constant, but polarity of solute it is low, that is polarity of drug it is low. That's why in case of the non-polar drug, it will show the less solubility into the polar solvent, and polar drug, they are showing the greater extent of the solubility into the polar solvent. And for this reason, the like dissolves like, this concept is very, very important while selecting the specific solvent to solubilize the solute and to form the homogeneous and clear single phase mixture. So this is the reason why polar solvents dissolves polar solute, why non-polar solvents dissolves non-polar solute. Okay, and the entire principle behind this polar, non-polar and semipolar, it is just like dissolves like. The concept of like dissolves like is to brief. Okay, so we'll stop here. If you have any query, any doubt, you may ask. Thank you. Thank you very much.